Okay, so now we're looking at exercise 14. This is 1, 2, 3, 4, 5, the sixth video. Okay, so there's a sixth video of exercise 14 on page 182. All right. So coming back to number 2. In number 2, the question says, check, this is 7.2, no? 7.2. State the coordinates of T, Q, R, and S in terms of P. So Q, so let's go with S. So firstly is going to be, what that one? T, Q, R, and S. Okay. So T, as you can see here, it's on your X, so it's P and 2, since it's on this line here. S is going to be P and some Y value, which we don't have. However, if we're going to substitute this P into the parabola's equation, and then I'm going to get negative, it will be half x squared minus 8. Does this make sense? Yes, it's positive, so the graph is smiling, and also cuts at negative 80. Alright, R, as you can see, this is on the negative part of the x-axis. So if this is P, then this is also P in length. So it's a negative part of your x-axis, which is minus P. And if I put negative P into the parabola's equation, I will get the same, which is half x squared minus 8. Okay, it should be the same because those lines are parallel to the x-axis anyway. Q is going to be negative P and of course 2. Okay, so there are a lot of information on this little diagram here. So T is going to be P and 2. Q is negative P and 2. R is negative P and half x squared minus 8. And S, of course, is P and half x squared minus 8. Okay, another piece of writing here. Let's put this here. Is P and half x minus squared minus 8. Okay, let's look at question 3. In question 3, we are told what type of quadrilateral is QRTS. This has to be a rectangle. Why? Because since these lines are parallel to your y-axis and those lines are parallel to your x-axis, this will result in this being 90, 90 and so on, and co-interior angles. So all of that will come out to be 90 anyway. So it's a rectangle. Okay, let's go to number 4. Let's see what the answer says at the back. Why it is a rectangle other than that. Okay, so they're saying about the same, more or less the same explanation here. So let's look at number 4. Question 4, we are asked to show that the area of the rectangle is given by. So how do you calculate the area of a rectangle? Area is going to be length times breadth. Okay. So if we look at this rectangle here, let's use the other color. Let's check here. Let's use it here. You see here, this rectangle here, that's going to be your length, and there's your breadth, or vice versa. So you see that this is 2 here, and this is of course 2.5 x squared minus 8. So what we say is to calculate this distance here. Say this was 2 and this was minus 1. Then we must have a distance of 3. How do you get 3? It's 2 minus minus 1, which is 3. So the same light here, we say then the length will be 2 minus this length here, which is a half x squared minus 8. Okay? So it's going to give you negative half x squared plus 10, in other words. So this length here is going to be negative half x squared minus plus 10. This is the algebraic expression for that length. Okay. Now let's look at the breadth. the breadth of course is going to be, if this is P and this is negative P here, so in total is going to be simply 2P. Okay, makes sense? So the area of course is going to be length times breadth, so it's 2P into negative half x squared plus 10, which is going to give you negative, so it's supposed to be P here. Sorry man, it's supposed to have been P. Okay, sorry about that. So this would be negative P cubed plus 20P. Alright, and that's what they wanted you to show that the area can be written in. Okay, let's look at question 5. In question 5, 7.5, determine the value of P for which the area will be a maximum. So for the area of the maximum area will occur at the first derivative. So it's the derivative of area with respect to P. And remember the area was defined as negative 3P squared plus 20P. Another thing I have to note at this point is, say for argument's sake you didn't manage to prove that the area can be written as negative P squared, P cubed plus 20P. And the next question is with regards to the minimum or maximum. You can use this in your calculation, even if you didn't get it, okay? And the reason why they give it to you is so that you can use it. So they apply the derivative, so it's negative 3P squared plus 20. And I set it equal to 0, so I drop that. So negative 3P squared is equal to negative 20, so P works out to be 20 over 3, the square root thereof. Okay. Now, of course, P can't be negative. P must be greater than 0. So I'm going to take it to be positive because we're talking about area. So the square root of 20 over 3 gives us a P value of 2,58 units. Okay. Okay. So let's look at number 6. Number 6, state the maximum area. The maximum area will occur at the maximum value for P. So area is defined as negative P cubed, so it's 2,58 cubed, plus 22 times 2,58. Okay, so that gives us negative answer cubed plus 20 answer. So that's going to give us in decimal 34,43 units squared. And then the last question, determine the equation of the tangent, 7.7. Let's go here. Determine the equation of the tangent at x is equal to 2. Alright. Again, if I had made any errors, please let me know on that number, errors that I haven't corrected. And these videos are free, or if there's a better explanation on something, or I have a misunderstanding of an explanation, please feel free to let me know on that number. Okay. So number 7. So we're looking at a tangent at x is equal to 2. Okay. So your P is 2, something. So if you now have to graph what they're asking. Okay, remember that is 2, something, so it's at this point here. Okay, so the tangent, so in other words, we know already this tangent is going to be positive. What else do we know? We know that, remember this is x equal to 2 and some y value. We know it's going to cut your y-axis to have with a y-intercept lower than negative 8. Okay, so all of that in mind. So what we need to do first is we need to work out the point of contact by substituting 2 into f of x. That's number 1. Then we work out the general gradient by the first derivative. Then I substitute in 2 and I'll get the gradient at 2 out. Okay. And then I substitute the point 2 and whatever I get out here into that equation. So let's do that quickly. So first the point of contact, I work out f of 2. Okay. F of 2 is then equal to, remember f of x is defined as a half x squared minus 8. So that's going to give you minus 6. The point of contact is 2 and minus 6. Okay, I will go on to the next video.